Hi, I'm Mithilesh. In this lecture, we're going to look up surface areas and volumes. Surface areas of certain solids, example cone, cubes, hemispheres, and some other solid objects. We will also verify their volumes and compute for a combination of them. Let's straight away start with an example. If I have a combination of two hemispheres and a cylinder of such a type, what will be my curved surface area of such a figure? Simple. It would be combination of curved surface areas of part 1, which is this, plus part 2 plus part 3, which combines to form a capsule. It is so simple. You just need to break down the figure into your known geometrical parts. Let's see how a problem on surface area can be asked. Remember our perimeter problem, which I've told you? It is so simple, but it is done in 2D. So I had calculated the perimeter of the circle and then found out the cost of fencing with 8 rupees per meter. If I have to paint a wall which is of such structure, imagine this structure is in 3D. It is just the difference between that question and this question. What will be the area which I have to paint? Here, instead of fencing, you're painting. So the area which you would have to paint is the outer portion of the platform, whether be it a rectangle or a square, that is this part. You need to find out the area of this part plus the area or the curved surface area of the hemisphere which is on the reverse side or which is kept on the plate. You need not find out this area as it might be a hole or it might be an empty crack over there. You just need to break down it into simple geometric figures and calculate the areas. You may find similar cases with the calculation of volume. You may need to memorize the formulas or you should learn to derive them. Consider the previous example and let's calculate its volume. For a planar figure, you cannot find volume for the square. Hence, you can find only volume for the hemisphere. Hence, you need to memorize all the formulas for a cube, a cone, a hemisphere, a cube, etc. in order to master this chapter. Usually things you come across in this chapter may be a cone, right circular cone, cylinder, sphere, cube, etc. So it is better if you keep in mind these volumes and surface areas. Now we'll see how to evaluate surface areas and volumes of sections when they are removed from a solid rigid object. That is one of the above. Before cutting, this is a right circular cone with me. So I find out the volume or the curved surface area when I am asked to, considering this as my radius and this as my height. So when I pass a plane, a parallel plane parallel to the base, then it becomes a smaller cone, isn't it? Then also I can apply the same thing, height and this part over here, the circular part. When I see it from this way, my diagram would be of such a sort. It is just a triangle from here. Sorry, pardon me, it is a circle from here. And if I see it in the front view position, that is parallel to my screen, it will be a triangle. If I minus the curved surface area of region 2, if I call this as region 2 and region 1, then 2 minus 1 will give me the remaining curved surface area. Plus, I have to add this part. When I cut off this part, I generate another part over here. Therefore, I have to add this part area if it is mentioned in the question. Similarly, if something is joining, suppose a same cone is again cut on the other side and is placed inverted to it, something like this, then you just need to add up. It's very simple. You just need to identify the simplest geometric shape present in there and you need to give it out. Specify the smallest part and then proceed with your calculations. Be careful with right circular cone as it is a little tricky. You need to imagine the figure in 3D. The point of the altitude which comes down is not exactly on the base of the cone but at the center of it. Practice all the problems in the textbook for this particular chapter as it is very important and you may expect a sure short question. Thank you.